Hello student. Today let's be derive an expression for charge in a circuit and also derive expression for current and voltage in the growth of charge of in a CR circuit. As we know that C is the capacitance, it stores the charges, and R is the resistance here. When you connected this to in series with the voltage E, then the total voltage is sum of the voltage flowing through the capacitance and resistance. Then the total EMF will be is given by E equal to voltage across capacitance and voltage across resistance. We know that voltage across capacitance given by the equation is charge per coulomb, that is the Q by C, and as usually the voltage across VR is R into I. When you charges, it reaches the maximum value Q equal to Q naught, then IR become 0, then E equal to Q naught by C. Then put this value in the equation, value of E equal to in 1, then we got Q naught by C, Q naught by C plus Q by C plus Ri, and put this value of I, as we know that is the rate of change of charges, that is I equal to dq by dc. Just I is replaced with this one, that is Q naught by C and Q by C plus R into dq by dt. Bring this side Q by C to the left side, then we simplify Q naught by Q by C, and R dq by dt remains right side. On simplification, that is dq, Q naught is going this way, that is dq by Q naught by minus Q, and 1 by Cr into dt, that is the equation 3. On integrate these two equations, we get minus log Q naught minus Q, because of the Q is there, that's why it is minus, and T is there, 1 by Cr into T plus constant C. For calculation of constant C, put the value of T equal to 0, then Q is 0, then C equal to minus log Q. Put this value in this place. On simplification, we got minus log Q naught Q equal to 1 by CRT minus log Q. Bring this side positive, and this gives the log Q naught minus Q by Q naught, and taken minus that side, that is minus Cr into T, and Q naught get cancelled, that is 1 Q by Q naught equal to 1 by C, then Q equal to Q naught 1 minus e to the power of 1 minus CRT, where Q is the charges flowing through it, Q naught is the maximum charges, 1 minus e to the power of 1 by CRT. This is the expression for growth of charges in CR circuit, capacitance and resistance circuit. When T is 0, Q is also 0 because of charging. The T is infinity, that Q is reached to Q naught, that is the constant value Q naught. If you raise the time, does not changes its charges and remains same. Hence it can be written as in the graph, as time increases, charges also increases, but after some time it goes on constant. If this goes on constant like this and reaches the constant value, that is Q naught. Here the time constant is there, product of capacitance and R is called a time constant in a CR circuit, and put this value Cr tau, that is time taken, that is Q is to Q naught, and last time constant is given by the 0.632 q naught, that is 63.2 percentage of it time charges. The time is called the time constant. If the maximum charge is that reaches 63.2% of its maximum charge, the time is required. Such charge is called the time constant here. As you know that the charges from the equation 5, q naught 1 minus v. If this equation is divided by c, this gives the voltage. Hence, we can be derived an equation 5 can be divided by c, then q by c, q naught by c. Q by c is nothing but voltage. Q naught by c is also voltage, that is maximum voltage. That is, it can be changes to charges to a voltage form is v equal to v naught 1 minus e to the power of 1 by c r into t for the voltage equation. If you want to derive for current, then also we can be derived. Just you are divide by this equation 6 by r, that is v by r, v naught by r. As you know that by Ohm's law, v is equal to ri, hence v equal to r is I, v naught by r is I naught 1 minus e to the power of 1 by c r t. This is the expression for current in the CR circuit, and this is for the voltage. 6 is there, this is for voltage. Okay, thank you.